Hey, today we're looking at divisibility rules. Our goal is to determine which prime numbers are factors of large numbers using a few tricks. So here are the tricks. For any natural number, that number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. So perhaps an easier way to say that would be if it's an even number, it's divisible by 2. Any natural number is divisible by 3 if the sum of the digits of the number makes a number that is also divisible by 3. We talked about that one before. It is divisible by 4 if the last two digits of the number form a number that is divisible by 4. So the last two digits means that you just have to be able to figure out the numbers between 0 and 100 that are divisible by 4. So that'd be like 4, 8, 12, 16, 20, 24, and so on. For 5, if the number ends in 5 or 0, it is divisible by 5. For 6, if the number is divisible by both 2 and 3, then the number is divisible by 6. So for that one, you probably already checked 2 and 3. And so if it was correct on both of those, then you could say it's divisible by 6 as well. It's divisible by 9 using kind of the same rules as for 3. So if the sum of the digits of the number makes a number that is divisible by 9, then the entire number is divisible by 9. And for 10, if the number ends in a 0, then it's divisible by 10. Okay, so we're going to practice these divisibility rules first. We're going to start with a couple of kind of large numbers there. So for our first one, this is 2,034,651. I want to test this one to see if it's divisible by each of the numbers up in our chart there. So I'm going to start with 2. And for 2, the rule was to look at the last digit. And if that last digit is 0, 2, 4, 6, or 8, then it's divisible by 2. Last digit on this one is a 1, so it is not divisible by 2. Next, I'll try 3. So to see if it's divisible by 3, I'm going to sum the digits of the number. So testing this one here, I would need 2 plus 0 plus 3 plus 4 plus 6 plus 5 plus 1. So that's a long string of addition here. We'll talk about some things that we can do to make adding easier also. 2 and 3 makes 5, and another 5 makes 10. So this grouping that I have underlined right now is a 10, and 4 plus 6 is 10, so there's another 10, and then there's only 1 left over. So if I group things like this, then I could say that I've got 10 plus 10, which is 20, plus 1 is 21. And so 21 is divisible by 3, so therefore this number, 2,034,651, is divisible by 3 also. All right, now for 4. 4 says we're supposed to use the last two digits of the number. So if the last two digits makes a number that's divisible by 4, then the entire number is. Now, actually, if a number is not divisible by 2, it can't be divisible by 4 either. But if you're using that rule, 51 is not divisible by 4. So anyway, number 5. So to see if it's divisible by the number 5, again, we're just looking at the last digit. The last digit has to be a 0 or a 5, and it's not. So it's not divisible by 5. For 6, it has to have a check mark on both 2 and 3. It has a check mark on 3, but not 2. So it's not divisible by 6. The next ones we had tricks for were 9. Now for 9, we're supposed to sum the digits. And we already summed the digits when we were checking 3, so we can actually kind of check 3 and 9 simultaneously. So the sum of the digits was 21. 21 is not divisible by 9, so therefore this number is not divisible by 9. And the last one we have to check is 10. So for 10, the last digit has to be a 0, and it is not. And this one you can kind of do simultaneously with 5 as well, since 10 is has to end in 0 and 5 also has that, that stipulation, then if it's not divisible by 5, it's also not going to be divisible by 10. So anyhow, we tested all of the numbers that we had on their list there, and of these ones that we have tricks for, 3 was the only one. So this one is only divisible by 3 on our list. So we're going to try that same thing with the second number here. If you're feeling kind of good about this, this would be a good place to pause this video and then try it, and then come back and see how you did. If you'd like to see another example in action, just stay with me and I'll go through it. So we're starting with 2. To be divisible by 2, the last digit has to be a 0, 2, 4, 6, or 8. Last digit is a 0, so this one is divisible by 2. For 3, we're going to sum the digits of the number. So I'd have 4 plus 2 plus 3 plus 5 plus 0. And again, I can kind of use my little trick here. 2 plus 3 plus 5 makes 10. So this is a grouping of 10. I just have to add then 4 and 0 to it. So that'd be 14. 14 is not divisible by 3. So that means this number is not divisible by 3. For 4, I'm looking at the last 2 digits of the number. The last 2 digits make up the number 50. 50 is not divisible by 4, so this number is not divisible by 4. For 5, if the last digit is a 0 or a 5, so I'm just looking at the last digit, it is a 0, so this number is divisible by 5. For 6, to be divisible by 6, it has to have a check mark for both 2 and 3. So this one has a check at 2, but not at 3, so it's not divisible by 6. For 9, I can go back and look at the work that I did on 3. And actually, if there's an X on 3, there's going to be an X on 9 also. If it's not divisible by 3, it can't be divisible by 9 either. And then finally 10. So for 10, we're looking at the last digit. Last digit has to be a 0, and it is. So this one is divisible by 10. So the of the ones that we had to try on this one, we found 2 was a yes, 5 was a yes, and 10 was a yes. Alrighty, next up we've got prime factorization.